Now let's talk about the properties of the carbonyl group. To understand the properties of carbonyl group, we need to understand the bonding within carbonyl group. So we know that the carbonyl group is a carbon that has double bond with an oxygen. So any carbon with a double bond will be an sp2 hybridized carbon. So the hybridization state of the carbonyl carbon is sp2. Also, the oxygen in the carbonyl group is an sp2 oxygen. So both of them are sp2. So the shape of the group is going to be a trigonal planar. So these groups are planar. The double bond comes from the hybridization of the two 2p orbitals. The other sp2 orbitals are involved in the formation of the sigma bond. We know that oxygen is more electronegative than carbon. We talked about electronegativity last lecture, and we know that oxygen is more electronegative than carbon. It has more tendency to attract the electrons of the bond between carbon and oxygen towards itself. So these compounds are polar compounds. These bonds are polar bonds. So the oxygen will always have a partially negative charge, and the carbon will have a partially positive charge. That will affect greatly the physical and chemical properties of the carbonyl functional group. So what are the properties of aldehydes and ketones? We are talking now about aldehydes and ketones, the carbonyl compounds. So the carbonyl, as we said, the carbonyl group is a polar group, unlike the alkene bond, which is not polar. Now there is a permanent dipole here between the oxygen and the carbon. So the small aldehydes can easily make hydrogen bonds with water. So small size aldehydes and ketone can mix or dissolve in water because they can form hydrogen bonding with water. And also they will have, because of the presence of the high of the dipole moment, there is a permanent dipole moment. That means that there will always be a dipole-dipole interaction between the aldehydes molecules or ketone molecules. So let's talk about solubility first. So the small size aldehydes and ketones will form hydrogen bonding with water, and that will affect their solubility with water. However, as the size increases, as this R group increases in size, then of course for aldehydes it's going to be hydrogen. For ketone there are two, both alkyl or aryl group. As these aryl groups increase in size, they will interfere with the hydrogen bond. So the aldehydes and ketone, which are big in size, will not be soluble in water as the small size aldehydes and ketone, because of the big size alkyl chain will affect the formation of the hydrogen bonding with water. Also, as we said, because of the C double bond O bond, or the carbonyl functional group is a polar functional group. This group has a permanent dipole moment. Will always be a dipole-dipole interaction between the different molecules in either in liquid or solid state. That means that the aldehydes and ketone will have higher boiling and melting points compared to their alkane or alkene counterparts because of the presence of the permanent dipole moment. We know that alkanes are only held together by their van der Waals forces, especially the London dispersion interaction, where there is an induced dipole interaction, which are very weak interaction. This is why alkanes have low melting and boiling points. But for the polar compounds, like aldehydes and ketones, they will have higher boiling and melting and boiling points because of the presence of the dipole-dipole interaction, which is a permanent dipole-dipole interaction. If you compare this with alcohols, you can see that alcohols, in addition to this dipole-dipole, they can also have hydrogen bond. Aldehydes and ketones cannot have hydrogen bonds with themselves because you have, for example, if you have an aldehyde like that, In order to form hydrogen bond, it needs another hydrogen that would be attached to an oxygen or nitrogen, and we don't have that for aldehydes or ketone. So the oxygen here cannot form hydrogen bond with other aldehydes or with other ketones. So the only form hydrogen bonding with water or with solvents that have an OH or an NH. For alcohols, on the other hand, alcohols have an OH group. That means that it can form hydrogen bonds within themselves. So the OH, now the hydrogen bond that is formed, can form between the hydrogen of one OH group with the oxygen of another OH group, like this. So the bond here will be between the oxygen or the lone or the oxygen of one OH and the hydrogen on the other OH. This is why alcohols would have higher boiling and melting points compared to their aldehydes or ketone counterparts.